Okay, now we want to try and factor a more complicated looking expression, although it's not complicated. Our first step is going to be to factor. We're going to factor each part because when we multiply, we want them to be in factored form so that they cancel. So I'm going to look at the top part there, and I'm going to say, 3x minus 3x squared. That looks like each one of those has a 3x in common. So I'm going to pull it out using the distributive property. 3x. Now to figure out what's left, I kind of do my division. 3x divided by 3x is 1. Negative 3x squared divided by 3x is negative x. Let's do the bottom there. I look and see my quadratic has nothing in front of x squared, so I'm going to split that into those two factors. I'm going to split up my x's, and I'm going to say what number can I multiply, what two numbers will multiply to be negative 5 and add to be 4? Definitely going to be 1 and 5. 1 times 5 is the only way to get 5. Now let's look at the sign. I want to get a 4 in the middle. If I want them to add to be positive 4, I better make sure my 1 is negative and my 5 is positive. Let's look at the other one. Another nice quadratic. There's nothing in front of x squared. Little scrunch there. Maybe we'll move this over. Isn't that cool how we can do that, huh? Alright. So we'll write this a little bit bigger. Another nice quadratic. We're going to split up our x's, and we're going to say, how can I multiply two numbers to get negative 20 and add them to get x? And that's definitely going to be 4 and 5. We want them to be a negative 20 when you multiply and add to be a positive 1. Can't see the 1, but it's still there. So we're going to make sure that that 4 is what's negative and the 5 is positive. If we wanted the 1 to be a negative, then we would have made 5 negative. Okay? Again, this factoring review can be found in Chapter 5. If you need to look at it again, feel free. And then the 3x, we're going to leave. Okay, so when I multiply, I put these all next to each other. Okay, so we're going to multiply straight across the top, straight across the bottom. And remember, it's really nice having all of our factors there because I can clearly see what is going to cancel. But I just had a red flag pop up. Look at these factors here. 1 minus x, x minus 1. We want to switch those around because they look like if I maybe pull something extra out, I can get another thing to cancel. And remember, we don't want any common factors at all. So let's look at this one. If I have 1 minus x, I can switch that around so my x is first. And that'll say negative x plus 1. Still doesn't match this guy there. We want them to match. So I'm going to say maybe if I pull out a negative 1, let's see what happens. So we'll factor out negative 1. What's left? I'm going to go negative x divided by negative 1 gives me x. 1 divided by negative 1 is negative 1. Look at that. They match. So I'm going to go ahead and change it so that they match. Oh, don't forget, we pulled out a negative 1. We'll stick that in front of 3x. It really doesn't matter since you're just multiplying everything. Okay, so let's take a look. Let's do some canceling. This is my favorite part. 3x on the top, 3x on the bottom. X minus 1, x minus 1. X plus 5, x plus 5. All that's left is negative 1 times x minus 4. We'll finish that off and distribute. We get negative x plus 4 is our final answer. Lots of work, however, stuff you guys have seen before, and we're just canceling. Treat it like a fraction. Okay, so now we want to multiply a rational expression by a polynomial. It's just like multiplying a whole number by a fraction. Whenever that happens, you're going to turn it into a fraction by putting it over 1. Now we're going to follow the same process. However, warning bells, I see a difference of cubes formula. Might need to look that up, but since I'm so nice, I'll give it to you. Okay, don't forget your difference of cubes formula. You should have this in your notes, or this can be found in chapter 5. So difference of cubes. Okay, and I noticed this because we have a cubed and a subtraction sign. So my difference of cubes formula, when you have a minus like that, tells me to take whatever I'm cubing in the first part minus whatever I'm cubing in the second part, we'll say 8. And then we're going to go that first one squared plus the first, or the second and the first multiplied, plus the last one squared. We're just reviewing difference of cubes, chapter 5. Okay? That'll help us factor it. So now let's do that step 1. Let's factor. X plus 2, already factored, don't need to do anything. The bottom part there, x cubed minus 27, that's where my difference of cubes formula comes in. I'm going to figure out what am I cubing in A and what am I cubing in B. If we called it A and B, it does not matter if we call it A and B or X and A. So what am I cubing in A, the first part there? Definitely X. X is what's getting cubed. What am I cubing in my second part? And definitely 3. Yes, most definitely. Okay, so that subtraction sign, we don't worry about it. That just tells us it's a difference. We're cubing 3. So x and 3 are going to go into our formula there. Okay, so we're going to go x minus 3. Now we're going to take the first one and square it. We're going to plus 3 times x and take the last one and square it. Difference of cubes. Look at that. I'm probably not even going to need to factor that because I just did one side and I found out that it matches. So let's multiply straight across. And then straight across the bottom. Lots of writing here, folks. And now we're going to cancel. Boop, boop. All that's left, x plus 2 over x minus 3. And that is most definitely your final answer.